The following presentation was recorded live at the 2015 National Bioneers Conference. To learn more about Bioneers programs and media products, visit www.bioneers.org.
Well, thank you all so much for coming. I hope you had a nice break and were able to catch up during lunch. We're going to get going on this panel. This is Natural Systems and Working Lands. We have three panelists today, two of whom you may have heard already, depending on when you're here, and a new one. My name is Teo Grossman. I'm the Director of Strategic Initiatives for Bioneers. So just by way of a quick introduction, and then we'll get going. Climate change is the result of human influence on natural systems, and the solution, as we've been told, as a result, has largely been focused on mitigating the human impact. Greenhouse gas emissions are the problem, therefore reduce greenhouse gas emissions is the solution. And lost in this sort of mechanistic and reductionist approach to the problem is the reality that degradation of ecosystems through deforestation and industrial agriculture and many other ways has directly increased emissions while also reducing the long-term sequestration ability of these landscapes and their capacity to buffer both human civilization from some of the impacts of a changing climate. I think we can all agree it's incredibly important to include natural systems as fundamental components of a comprehensive climate policy at multiple levels. And for those of you based in California, research shows that our forests are actually, over the past couple of years due to the fires, have actually moved from net carbon sinks to net carbon sources, given the quantity of fire. So there's a very clear need to integrate natural systems into the solution side of climate change. I'm going to introduce the panelists as they come up. So we'll start with, we are going to start with Ellie Cohen, who is the CEO of a group called Point Blue Conservation Science. And Ellie is a leader in catalyzing collaborative nature-based solutions to climate change. Point Blue's 140-plus scientists work to reduce environmental harms and promote climate-smart conservation for wildlife and people. Ellie chairs the California Landscape Conservation Cooperative, is a co-founder of the Bay Area Ecosystems Climate Change Consortium, and is a member of the National Wildlife Federation's Climate Smart Conservation Team. Point Blue, as an entity, helps policymakers and land managers understand both the science and policy structures that can help unlock the true potential of natural systems for carbon sequestration. So we'll start looking at natural systems and rangelands and ecological systems, and we'll sort of slowly move to more managed landscapes and agroecology and traditional agriculture as we go through the panel. So help me in welcoming Ellie Cohen.
Okay, great. Oops, sorry. Thanks so much. Thanks for that nice introduction. That was going to be my first slide, but some of you may know us if you're from the area. As Point Reyes Bird Observatory, we were founded 50 years ago this year, and today, as Teo mentioned, our 140 scientists work from the Sierra to the sea and actually all along the Pacific Flyway and as far away as Antarctica. And a lot of our work is studying birds as indicators of environmental change and working hand in hand with habitat and wildlife managers. Our highest priority today is to reduce the impacts of climate change and other environmental change to benefit wildlife and people. Yes, we are at this incredible tipping point. One of our lead employees who works in working lands and manages our rangeland watershed efforts is named Wendell Gilgert. Wendell actually spoke here last year and was on a panel. And Wendell's a fourth-generation rancher from the Central Valley. Wendell told me a story of, in the early 1980s, being in some of the foothills of the Central Valley here in California, which are not even brown. They're gray now. It's so dry. And he met with a Native American elder who described to him what it was like when that elder had been young. And when this time of year in October, which is normally a dry time of year for us anyway, but exacerbated now but from 4 years of severe drought, that you could actually see salmon up in the creeks in the foothills of the Central Valley. That was only decades ago, and today it's just so dramatically different. But I start with that story to paint a picture of what's possible if we employ nature-based approaches to addressing climate change as part of the climate change toolbox. It is possible to bring some of that back. Oh, sorry. So this, I didn't mean to go, so this slide here is just to say that there are multiple studies globally that are showing that we are, in fact, exceeding what some people call these planetary boundaries or these tipping points. And in one study, for example, where they chose 9 main areas of study, we have surpassed the tipping point on 5 of them already. So we're definitely on an edge of some kind, but we are still at a place where we can reverse it. Jim Hansen, who was formerly our national climatologist, and his studies on climate change, he just retired last year. He was the head of the NASA climatology area. And he is someone whose studies, unfortunately, have always shown to be true down the road. His latest study shows that, for example, we may face 10 feet of sea level rise, actually, by the end of this century. And other scientists were not eager to jump onto that bandwagon. But one of the things that Jim Hansen said, it's not a bandwagon, actually, I should say, it's from incredible science with 13 other lead scientists from across the globe. But it's very cutting edge and very provocative in the sense that it really challenges us to think this isn't just about the next generation. It is absolutely about us today and what we need to do. And one of the things he said that was so uplifting to me was that he believes that even though you'll hear from some people that we have so much built into the system, there's no way to reverse it even today, he believes that in fact we can, that it comes down to simple physics, to the heat budget of the planet, and that we can reverse it, but we absolutely must act today. And we heard some great talks this morning about a lot of the different work being done. So at Point Blue, we are working on what we call climate-smart conservation. And in essence, it's a way of addressing climate change, but tying it to other environmental impacts. And it brings together mitigation, greenhouse gas reductions, and adaptation, preparing for the challenges of climate change. And so our goal here is also to sustain nature, because in the end, whether we live in an urban area or whether we live in the middle of the Amazon jungle, we are all dependent on nature's benefits for our very survival. We could reduce all of our greenhouse gas emissions to 0 today, and we still have to have healthy ecosystems to produce the air and water and other benefits of nature that we are utterly dependent upon. Some key principles of climate-smart conservation: focusing on the future. Any kind of work we do is local, but putting it in that bigger context, and that is true in any sector. Employing flexible and adaptive approaches, prioritizing actions for multiple benefits, collaborating and communicating across sectors, which is a lot of what our session today is about, and practicing what I call the 10% rule, that we have to test and experiment every day because there's nobody above us that's going to tell us what to do. We all have to try new things to solve the big challenges of our time. One of the issues in the conservation world is that if you look at this is my stool of life. It has multiple meanings. And on the right-hand side, is biodiversity. In the conservation world, much of our success in the last 4 decades has been from focusing on single species through the Endangered Species Act. And it's been a little bit of a problem because if we only focus on that leg and we don't focus on the other 2, water and carbon, what happens to our stool of life? It collapses. And one of the things that we're learning now is that we need to look at things from a multi-benefit solution approach. And again, this is true not just in the conservation world, but in other areas of decision-making around climate change. We need to look at carbon, we need to look at water, and we need to look at biodiversity. If we only look at carbon, then we might decide that all we want are old-growth forests in the Sierras that never burn down. And what that does for water, does anybody know? It sucks up the water and transpires most of that back out into the atmosphere. And in fact, from an ecological point of view, you need a balance of all of this. So we have some interesting trade-offs and decisions to make. If we decided today that the best way to go with forestry was that we're going to plant the densest trees possible, we could capture a lot of carbon in a very short period of time with a very high risk that it would burn down at some point in the next few decades. But you could capture a lot of carbon really quickly. But you would lose a lot of water, and you would lose a lot of biodiversity that are all influencing one another to sustain the healthy ecosystems that support life as we know it. So really interesting challenges. At Point Blue, we have a high priority of working on rangelands, and we're targeting 1 million rangeland acres to change grazing practices. Current grazing practices, for the most part, have essentially pounded the ground so hard that it's turned the ground into a tabletop. So the last time we had big rain here in California, if we can remember way back to November and December of 2012, we had probably 22, 24 inches of rain in the Central Valley. Almost all of that ran off into the ocean. Our goal is to bring back the natural sponge of the soil, healthy soil, to sequester carbon, hold that water in, produce more plants with long roots, long perennial grasses that, again, break open the soil, allow it to hold water, and then support the other functions of life. And we are now today on over 300,000 acres. We're doing it through a model. One of my goals today, as Theo asked, was to talk about different models for how we make change. And in my world, one of our models is to essentially embed biologists into the Natural Resource Conservation Service regional offices. And so you've heard of embedded media in war zones. So we embed biologists in a different kind of war zone to fight for our future and to build relationships with ranchers and other private lands managers. Think about it. Across California, half of the land is private. And of that, of grasslands are about 40% of all California and about 40% of the world's land base. So we have an opportunity to make a big difference if we can turn it back from that tabletop to a living sponge that really does sequester carbon and hold water and support biodiversity. And I won't go into all this. I'll jump ahead here. We've also established what we call a rangeland monitoring network to measure biodiversity, wildlife, vegetation, carbon, and water, and to find a simple way to do it so that many more people can take advantage of emerging markets, for example, in the carbon market. We have a how-to handbook and have online tools, and we hope to expand that. And our goal is open sharing of this information, not to hold on to it. The sooner we share the information, we get feedback about what works and what doesn't, and we can continue to improve it. We're also working on climate-smart riparian restoration. Riparian restoration has been identified as a key way for us to reduce the impacts of climate change, whether it's flooding or drought, or changes in phenology, which means changes in the life cycle of animals, where birds, for example, might come earlier in the year or stay later. And we plant plants that can withstand some of these changes and test different ways to ensure that restoration works into the future. Not only that, recently there was a study done here in Marin County that it hasn't been published yet, but that shows that older restorations, riparian restorations, sequester a huge amount of carbon. And so you can really, to sequester carbon in the soil, you need a lot of water. So you can really imagine how these riparian restorations could do this pretty quickly. In the Central Valley, something like 95% of these riparian corridors are completely gone. Imagine what will happen in this El Nino winter when it pours down rain, we hope, but not in a deadly way, we hope. That if we had more healthy riparian areas, we could really be taking advantage of the water in better ways ecologically and economically. Some of you may have heard of Marin Carbon Project and the Marin Resource Conservation District. They are doing an effort of carbon farm planning, where they're working with farmers, and the Natural Resource Conservation Service is starting to adopt some of these practices, and they can really look at multiple approaches to make that soil healthier, to sequester carbon, and also sustain biodiversity. So it's not just compost. It's very expensive to do that. And the NRCS is looking at a practice to approve it. They have an interim practice now. But the cost, let me just take a step back. Today we were talking about low-income people, and we just have to remember that we have urban low-income communities. We also have rural low-income communities. And they may not look like what you imagine as low-income, but even somebody who has 5,000 acres of land, many of these ranchers are barely making it, and they stay because they love the land, or they're the fourth generation doing it. Most of these people are not wealthy. Most of these people are trying to do what's right. And so it's an interesting cultural and ethnic, a different kind of ethnicity, if you will, that our scientists are working with and helping to learn from them, and also to help them see new ways of doing things that will have both ecological and economic benefits. And this is an example of something that Marin Carbon Project did, calculating carbon on one ranch. And we heard earlier today from Amy that There's roughly 459 million tons of carbon dioxide equivalent, and the potential for sequestering carbon in rangelands in California is huge. This one example showed just the compost application was 1.4 million tons of carbon dioxide equivalent per acre per year. And if we were able to do that on every acre in California, not just the compost, but the different ones, that's 40 million towards this, and we think there's actually much bigger potential than that. So very significant possibility. I just want to remind us not to forget that the forests are actually working lands. We work across the Sierras in partnership with the U.S. Forest Service, and there is this trade-off of how we manage forests for all these different benefits and to mitigate for fire. But fire is a natural part of the Sierra Nevada ecosystem. And also mountain meadows, they're only about 1% to 2% of the Sierras, but critically important as we lose snowpack and also very significant storage of carbon. So key principles, collaborating and communicating across sectors. It could be scientists with farmers. It could be older people with youth. It can be with urban youth and with rural youth. There are many, many sectors and boundaries that we need to cross to come up with better solutions for a secure future. We also need to think about local governments. There's an incredible opportunity today from new laws that were just signed into being by Governor Jerry Brown this past week. If we can engage cities and counties and local agencies in developing that full toolbox for climate change solutions, we have a great opportunity to make a difference. We also heard somebody earlier today say that 80%, up to 80% of climate change solutions really will come from the local government level. And for us in the conservation world, rarely do we interact with local government. We're starting to do that with sea level rise models at Point Blue, but there's so much more opportunity there. Just to wrap it up, this is some of the new legislation for those of you outside of California that's huge, that brings in nature-based solutions. One requires counties to address climate adaptation in their general plans every 5 years, and it does include identifying natural infrastructure. I'm happy to share this with you at another time, but it's very significant, the legislation that's been passed and signed into law in the past few months here in California. Very exciting to be a part of it. And also, President Obama just released a new policy guidance last week that directs all federal agencies to incorporate the value of natural or green infrastructure and ecosystem services into planning and decision-making. So huge opportunities for us to bring the science to the decision makers. And there are other ways to work with decision makers in all kinds of entities that we call scenario planning that helps people see a different kind of future. Collaboratives, there are multiple collaboratives from CalCan and so many others, the one that you mentioned that I helped to found, the Bay Area Ecosystems Climate Change Consortium. And all of this is about breaking down barriers, learning from one another, and doing the quickest problem solving we possibly can. So let's all remember to apply the 10% rule every day, test and experiment now. We're all responsible for our future. No more business as usual. We have to reverse greenhouse gas emissions, transition to clean, efficient, and equitable energy and water use economy, make protecting nature's benefits an equal priority through climate-smart conservation. So our vision for the future is that California's open spaces are preserved. The biggest pressure is human pressure and development. Working lands are economically sustainable and managed for multiple benefits ecologically. And we have an engaged network of land managers to share information. And here's my headline for August 2030. If we're successful, major investments in nature-based solutions pay off. Water flows despite drought and snowpack loss. Our vision is, because of our collaborative climate-smart conservation actions today, healthy ecosystems will sustain thriving wildlife and human communities well into the future. Thank you.
Thanks, Ellie. For those of you who were here in the morning, you know Greg quite well at this point. For anyone else, Greg Watson is the Director of Policies and System Design at the Schumacher Institute, based out in Cape Cod. He's one of the Bioneers board members. He's done a huge number of other things. His bio is in your packet. Greg. 2 minutes.
Yeah, I was going to say, no, the timer gets timed, right? This is going to be very interesting. I'm going to talk about working lands, and I'm going to focus a little bit on agriculture. As you probably could tell from my bio, that I have served as Commissioner of Agriculture in Massachusetts, 2 different stints, 20 years apart, which gave me a sort of a very interesting vantage point in terms of our agricultural system there. And I'm going to tout a little bit Massachusetts. We had a lot of touting, and rightfully so, of what's going on in California. But I would like to point out that, trend-wise, starting or at the end of the Second World War through the mid-1970s, Massachusetts was losing about 10,000 acres of farmland a year and 200 farm businesses annually. 10,000 acres, 200 farm businesses were going out of business every year between the end of World War II and the mid-1970s. To a large extent, folks felt that that was inevitable. This was a day of cheap energy. It didn't matter that we were importing our food from 3,000 miles across or even further from outside the country, that we would become a high-tech state, and this was just sort of the part of the sort of the natural part of economic development. We had and that meant we were losing our major resource, obviously our land. You can't talk about doing any of the stuff we're talking about in terms of preserving sustainable agriculture, anything without that land base. And we were just seeing it just disappear beneath our feet. Fortunately, we had a commissioner of agriculture back then, before I came on, named Fred Winthrop, who asked the very simple question: is there anything that we could do as a state? I'm going to focus a little bit on policy. That's part of what I'm going to be looking at, that the state could do with its own resources to stop that hemorrhaging. And you got to understand, when you've got a trend that is that powerful, it's been going that long, it is very difficult to take that train and not only stop it, but try to turn it around. But he commissioned a small group, Blue Ribbon Commission, to come up with some policy for food and agriculture for Massachusetts. That was published in 1976. It's the first state, I think we were the first state to publish such a policy, and it was only 24 pages long. But here's the key. One of the things that Fred said is we have to get public support for, and this is in Massachusetts, not a major agricultural state, for preserving our prime agricultural lands. And one of the things we had to do was dispel this myth that small farming is not economical. It doesn't make any sense, right? And that was sort of the growth. And that in and of itself is a myth, right? And there's no policy decisions at the federal level sort of really sort of created the impression that only large industrial agriculture. That was not a matter of economics. That was a conscious policy decision on the part of, I'm not going to put it all on one person, but certainly Earl Butz and that crew was at the head of it, where they were very proud of the fact that only 5% of the population provided the food for this country. They thought that was a great deal. And the system was set up, let's face it, the system was set up to subsidize and support not the farmers who were growing for Wall Street, not Main Street, right? It was commodities. When you look at how it's set up, structured, there are certain crops that are called commodities, and that's the wheat, the soybean, and it's not, I'm not saying it's all bad, but geared towards, again, where can we market that on the international market, Wall Street? What do they call the things that we grow in Massachusetts, which is spinach and broccoli and tomatoes and apples and peaches? We're called specialty crops. Specialty crops. So, well, wait. There's this image that what we're doing are the things that aren't necessity, and everybody else is growing the stuff that staples. So there was that was the setup there. We had to sort of overcome that. And so what Fred did was say, one of the things that we're going to do is we're going to go to the legislature and we're going to raise money to protect our agricultural land. And this is, I'm going to ask and wonder how many people know this, but since the 1970s and up until today, our state has invested $100 million to preserve over 800 acres of prime agricultural land. And the way that we did that was create a program called, and we were the first agricultural preservation restriction program. And basically, what we said is we're going to go to farmers who feel that, because our farmers were hurting, they were suffering economically, and the pressures to develop were tremendous. So what the state said was, you know what, we understand the pressures to develop are tremendous, and what we're going to do is we will offer farms with prime agricultural land, quality, because we're talking the quality of the land, which is soil. We're going to get to our issue of climate change and carbon capture and that sort of thing. But for a farmer that's being tempted, we'll pay you the difference between the agricultural value of your land and the development value of the land. Give you cash. It's cash, and it's yours to do whatever you want to do. You still own the land. You can still sell it. You can still pass it on to your kids, but we purchased the right to develop it. It must forever remain in agriculture. The land, at least that part we bought. And farmers said, okay, so we said, this APR program, again, $100 million over the years, 800 acres of land that is forever preserved for agriculture. But we also went one step further. That policy didn't just do that. The policy said there are other things that we could do that may not seem like a direct impact on doing this, but will have some beneficial impacts. We reinstituted support for direct marketing. That may seem like a trivial thing, but back then, most of our farmers sold wholesale. So you sell wholesale, you're a small farmer, what you're going to do is bring a truckload of potatoes, you're going to bring a truckload or whatever it is. That marketing system encouraged monoculture, right? Because that's we're small farmers, they've got the big Chelsea wholesale market that's set up for trucks coming in from the Carolinas and California. They said, you come in, you drop off what you can quickly, we'll check it off, and then get back to your farm. By just offering the options for more direct marketing, particularly farmers markets. That's one of the first things I did back in 1978, 79 was organize the Boston farmers markets. What we did, we said we want to help farmers convert from being purely wholesalers to at least partial retailers. Now, when you start to retail, a bunch of things happen. One is you can probably, ideally make more money because you are cutting out many of the middle, and I will say I'll use this term middlemen because that's what most of them were back then. And so that, when you looked at the system as it was set up back then, the major beneficiaries of that wholesale system were the people in the middle, and the folks who really benefited the least were the farmer and the consumer, right? So we said, let's try to figure out a better way to do that. And so when you did that, though, the interesting thing was by converting them to retailers, farmers started to diversify. They said, if I drive in from Orange, Massachusetts to Dorchester and all I got is potatoes, I'm probably not going to do that well. But if I've got some potatoes and tomatoes, and what else would you like to see me grow? Can you grow collards? I didn't know there was a market for collards. I can grow collards. Question is, will you be there? Will this market be there? So setting up these markets, we not only found that they were more responsive, but they were actually listening to what the consumer was saying, and they were doing what we were trying to preach to them to do for ecological reasons. I think someone brought it up this morning. You provide the economic incentives to do the right thing, and if that works, then you'll find that, the unintended consequences of direct marketing, they're all beneficial. So we've been able to sort of now preserve that land. By the way, in the last agricultural census, Massachusetts was one of a handful of states that actually saw a slight increase in both numbers of farms and farmland acreage. So we not only stopped that hemorrhaging, we turned it completely around. So I got 2 minutes, and I'm going to make one link, and I'm going to follow this up tomorrow on and this may seem like a real stretch, but we're also now, what I'm doing at the Schumacher Society, Schumacher Center, used to be the Schumacher Society, real quick. After a quick visit, we did a delegation to Cuba in October 2014. This was right before Obama and Castro shook hands and said they're going to try to renew diplomatic relations. But we went there to look at the sustainable food system. And I went there primarily because I was interested in urban agriculture, and someone said, what's the best example of urban ag? And I said, I think it's in Cuba, and it turns out you're right, so let's go there and take a look. Here's the long and short of that. What we discovered was, and you probably already know this, but seeing firsthand, I had read it academically and read in journals about the great experiment in agriculture in Cuba. During I am going to be really brief here, but Cuba was once the largest user of mechanical equipment and chemical fertilizers in Latin America. This was during when the Soviet Union was there, and they were depending on Soviets. They got a lot of input. The largest user of chemical fertilizers, pesticides, and mechanized agriculture. After the collapse of the Soviet bloc, right, and the withdrawal of their resources, where there was no longer access to petroleum, to chemical fertilizers, pesticides, and the average Cuban, right after that happened, was losing an average of 15 to 20 pounds. The government went to the farmers and said, you got to find a way to grow without chemicals or we're going to starve. And this incredible agroecology program evolved, not out of ideology, not out of protest to chemical, but it's because you've got an alternative. You've got at least the ultimatum. Find a way to grow without this or starve. And this system has, in fact, again, agroecology, farmer-to-farmer education, and cooperatives. But here's the deal on soil and carbon capture, because we are finding, at least Rodell and others, that the quality of the soils, how the food is grown, has an impact on its ability, right, to capture carbon and to increase soil fertility, as opposed to just, because the structure makes a big difference. One of the things that we think we have, that Cuba offers, because now the veil is being sort of lifted, They went through a number of years where they were the heaviest users of chemical pesticides. Then they went through a period where some of those lands were converted from chemical to organic agriculture, and then there's some lands that were virgin all the time and got converted to urban agriculture because they needed to grow as quickly. So we've got a place to examine over time how the different agricultural practices, the impacts they do have on soil quality, and again, to quantify that over time, and that I'll be talking a little bit more about that tomorrow, but it's an incredible opportunity, and that's sort of a result of what we've created called the Cuba-U.S. Agroecology Network that we're establishing out of the Schumacher Center. So, thank you.
Thanks, Greg. Renata Brillinger.
That's the German way.
German, or I'm a Grossman. Renata Brillinger is the executive director and co-founder of the California Climate and Agriculture Network. If you were here this morning, you heard her. Her bio is in your packet.
Thank you, too.
Yeah.
All right. Well, I told you almost everything I know in 20 minutes earlier today, so I'm just going to see if I can dredge up something else of value and not repeat myself from the morning. Not to mention, these two already, took most of the rest of what I might have said, like you said you would. Actually, I'm thrilled to be last because what we do in the policy realm relies on experts like these folks, the biologists, the conservationists, the economists, the folks who actually know how things really work, because policy can be theoretical and therefore not necessarily that usable unless you ground truth it and turn to science and practitioners. So that's a big part of what we rely on. Talking about policy without that is vacuous. So in addition to not having much more to say personally, I'm now going to even cop out more by actually relying on another great thought leader, Wendell Berry, who I'm sure many of you have read a little bit of over the years. He's now in his 80s, I think, and he's a very interesting Renaissance man, a farmer, an activist, a poet, an author in Kentucky. Still really productive and incredibly thoughtful. And he wrote an essay, it was actually a chapter of a book in 1977 or something like that called Solving for Pattern. And if you haven't read it, go Google it. It's online. I forget the title of the book, but just type in Wendell Berry Solving for Pattern. It's a very short little read. And it's as applicable today as it ever was. The examples he gives in agriculture are just as relevant. And this idea never gets old to me, this concept of solving for patterns. So it's kind of complicated the way he describes it, but the key piece I want to focus on is that when looking at complex problems, we need to come up with solutions that solve multiple problems. We can't just look for silver bullets, tempting as that is, desperate as we are for true, solutions and hope. And therefore, we would want, we kind of want it to be simple. We want to be able to do it. We want to be able to fix it. But it's not going to be like that. And I think it was David this morning that said these are long-term solutions, right? You were talking about that, that need to be unfolding. And it's as true, or maybe most true, in when you look at land use or natural resource use. The changes are not going to be overnight, and the solutions I don't think are going to be high tech particularly. So anyway, I just wanted to just kind of quickly reiterate some of the complex problems that we're facing in agriculture. Some the result of agriculture, some the result of climate change, other things. We've got drought. I've talked about this morning too. And we've got contaminated groundwater, the result of, in part, of nitrogen fertilizer application that over-applied and it leaches into the groundwater and makes drinking water undrinkable. We've got air pollution. That's the result of dust from agriculture. It's not just agriculture, but I'm just focusing on ag. Particulate matter that causes health problems. Nitrous oxide, again, from nitrogen fertilizer application that volatilizes off and becomes a greenhouse gas. Other greenhouse gases come from agriculture, methane and CO2. We've got tremendous vulnerabilities in our farm worker population. For all kinds of reasons, we're losing ag land at an insane rate. We've got salination of soil, the result of irrigating and then having the soils the salts concentrate in soil. We've got subsidence of land, the land sinking, and then, of course, all these climate impacts in addition to all that. So it's very, very complex. There's all kinds of harms and problems, not just to humans, but ecosystems and other critters. So solving those those problems we're going to need to tackle them by looking at solutions with multiple benefits, as Ellie talked about. So I just want to talk really quickly about 3 different examples of this. So reducing or eliminating the use of synthetic nitrogen fertilizer would be a good place to look. Nitrous oxide is a potent greenhouse gas. We can do that in a number of ways. I'm going to pick 2 to talk about to contrast the distinction, I think, between them. We could, for example, apply chemicals when we apply the nitrogen fertilizer that increase the efficiency of that fertilizer, the accessibility of that fertilizer to the plant. So we could put another chemical on. There's some studies that have shown that has some value in terms of nitrous oxide emissions. But it does nothing about soil health, for example. It does nothing to get us off fossil fuel, which is, nitrogen fertilizer is incredibly energy intensive to produce. So it may help on the farm if you took that little box, of the farm, but in terms of greenhouse gases only. Again, Ellie mentioned this. We really need to be looking at watching out for false solutions or for ones that underachieve their potential to solve a number of problems. Improving soil organic matter. So an alternative to applying these chemicals that increase the efficiency of the plant to use nitrogen is to start using cover crops or applying compost or manure. That does a whole bunch of things that have greater benefits across the board. And those are the kind of things we need to subsidize or incentivize. Improving soil organic matter, we've talked quite a bit today about the multiple benefits of doing that, so I don't think I'll dive any more into that, but it produces tremendous co-benefits in addition to reducing CO2 emissions. Conserving farmland, if we can figure out ways to do that and prioritize farmland that's around urban areas, again, I talked about this a little this morning, if we do it in conjunction or in tandem with smart growth and infill development and transit-oriented development, we'll get a whole bunch of co-benefits that come along with that. We'll get more livable cities, more affordable cities. We'll get reduced greenhouse gases from vehicle miles traveled, because people will be less in their cars if they're surrounded by greenbelt and their needs are being met in the urban areas, as opposed to sprawling out into, malls and suburbs. So, and we'll retain wildlife habitat, all the ecosystem services that come with keeping open space, all the recreational potential, all the food production potential of that ag land or rangeland. So then I'm just going to switch gears here and talk a little bit just in the last couple of minutes about policy tools. So there's primarily 2 levers to pull on with policy. There's regulation and there's incentives, carrots and sticks, primarily. There's some other hybrids of these. And in the regulatory arena, there's certainly been some recent laws that have been passed that limit the harmful types of farming practices, and some of them are really important and necessary. Things like banning open burning in the valley of trees and orchards and stuff like that, or rice even longer ago. They used to burn the debris or the residue of rice fields. And that caused tremendous air quality problems and pollution. More recently, there was a law passed last year, a set of laws, the Groundwater Regulation Act, incredibly important to move us towards a more sane monitoring and eventually regulation of groundwater use. Those things have a place, and I think incentives also have a place. And so when we look at cap and trade, which I talked about this morning, that creates a revenue source that can be distributed to farmers, in this case, who are willing to implement practices that have climate benefits. We already have the Farm Bill to look at. Ellie talked about NRCS. Those are conservation. NRCS distributes funds to landowners to do conservation practices on their land, and that's taxpayer money in that case. And those have been tremendously powerful and important for doing all kinds of important conservation-type practices on farms. It's the single biggest conservation program in the country. And our theory around incentives is that what we need to do often is kickstart with subsidies, with incentives, a set of incentives, encouragements to shift practices, and eventually those practices will become common, and we can start withdrawing some of the subsidies, much as happened in the solar industry. We made public investments in the beginning, and then private sector eventually takes over because it's the profitable and logical thing to do, and a whole industry gets built up around it, and then we can start pulling back on some of the incentives. So I would say, just in closing, that we have collectively an opportunity at this point with our California Greenhouse Gas Reduction Fund, and I would even say as much as a responsibility to, and we have a source of funding, to really seek the most transformative options and tools in agriculture to achieve these multiple benefits, to solve for pattern. Sometimes it's going to be incremental. It's not going to be always super transformative, but we need to move the whole continuum along in a direction that points towards ecological sustainability and resilience. And that's what we're going to need your help to do as we keep pushing with the legislature and the governor and the agencies implementing these programs. They're new, they're evolving, and they're going to need a lot of public input and a lot of smarts and a lot of strong voices. So if you want to get involved in that, just get in touch. So thank you.
Yeah, so when you guys come back up, and it's a small enough room, I'm happy to use mics if you want, but or you can just shout out the question. If anyone has questions, this is a great chance to engage with this panel. I can repeat the question, sure. I can start us off if no one wants to. No, go ahead. So the question is whether the panelists are familiar with permaculture as a related and similar approach to what they're talking about?
Yeah, I mean, I'll start. Yes. No, it doesn't. Well, anyway, can you hear me? Yeah, of course you can. My daughter always said you can hear me no matter where I am in the mall. She said, I can find you, Dad. Yes, permaculture, starting back from my days at the New Alchemy Institute, have always, at least for us, and I think we're finding more and more farmers are looking at the integration of perennials and the whole, and vermiculture as part of it, as part of that technique in terms of sustainability and resource efficiency. And I will say, and again, in Cuba, it's become embraced as sort of the umbrella. It really has become sort of the context for everything to do because of the vital need to use almost every resource and to extend that growing season and to look at the role at the multi-layered sort of agricultural landscape can play. So it is absolutely critical. I don't think it's quite has become ingrained here. I think it has more with some of our small farmers and certainly some of the ones that are working in, I think both in California, and sort of interesting because even though California has much larger farms, I think California and Massachusetts have a lot more in common than, say, Massachusetts and sort of the Midwest, just because of the nature of what's being grown.
Renata, could you tell us a little bit about the larger implications of the work that's been going on in California with the addition of compost to rangelands, and how much of the carbon that is being released currently in California could we ultimately offset by a full-on program of rangeland composting, and even extrapolate a little bit further, if you would, to tell us what the implications are for the United States as a whole?
So, John, right? Oh, that's not working either. John's referring to the work of an allied organization, the Marine Carbon Project. Also, another group to look to is the Carbon Cycle Institute. They're related, and they sort of one came out of the other. And they're the ones to ask that question of in terms of their data. They did some, but I'll tell you, generally what they've done and what they're advocating for. They worked with a UC Berkeley researcher and applied compost on rangelands in Marin County and also in the Sierra foothills. And demonstrated some really exciting possibilities in terms of jump-starting the biology of the soil on those rangelands, and therefore, creating this cycle of biology that pulls carbon out of the atmosphere and stores it in the soil. They took that data and modeled it in some black box that I don't understand, and predict that effect of storing that carbon would persist over some years. They say 30 years, or the computer said 30 years. And so that's really provocative and really hopeful. And as far as, extrapolating that to, to acres and tons of CO2, I think there are a lot of questions about what would make that possible. It would be quite expensive. So the money could come from cap and trade, which is a big piece of what they're looking to do. There are other feasibility challenges with getting compost on rangeland in California, where there's a lot of, a lot of remote areas, a lot of hilly areas. Actually, physically spreading that compost. There's some feasibility questions to overcome that they're also working on. So it's really a fascinating idea and clearly some promise there. And they also have been looking at, and Ellie talked about this a little bit too, they're looking at other practices that could maybe synergize with that compost application. They looked a little bit at intensive grazing, they looked at keyline plow, and then some of them at the Carbon Cycle Institute are actually expanding this even further into whole farm carbon planning. So yeah, check them out. And we're certainly aligned in many, many ways, because again, using biology as opposed to high-tech solutions or industrial scale solutions is, we think, going to be more effective overall.
Great.
Can I just piggyback?
Oh, go ahead. Yeah.
Again, this is not directly about California, but in Massachusetts a couple of years ago, the Department of Environmental Protection banned the landfill disposal of all commercial organic waste, right? So from restaurants and all. So that now has to either be, it's either going to be done in an anaerobic digester, but most of it's being composted. And the interesting thing there is that with our increased interest in urban agriculture, and most of our urban farms are on lands that can't be farmed directly, so they have to be sort of built up from using compost and raised beds. What we're finding is that because of that policy, what's happening in many cases is that since it makes the folks who are composting actually get more from tipping fees and trying to sell their compost, that many of them are actually donating much of that compost after it's composted, so that they can then be in a position to accept the organic food waste coming from from restaurants and places like that. So it's just become an integral part of what we're trying to do as well, even in a small state.
Thank you. And that was a good explanation about Marine Carbon Project and their work. What I want to emphasize is that it's been tested only on a very small scale, and they themselves are not sure that it can really work on a big scale. It's not a solution unto itself. It's part of a whole toolbox of approaches that could be used. And your question was also, could it be applied to the whole country? Specifically, they're testing it on grazing lands, and that's what the science has shown us. What it might do in other places is not part of their research specifically. But the hope is that it will be one important tool in a bigger toolbox. A key that you all are very familiar with is looking at the entire life cycle. So it's easy to think that one thing is a solution, and then you look at what it really costs in terms of carbon pollution or other kinds of costs, and you find out that the compost application on the scale that's needed might work near urban areas, but might not work in more rural areas, for example, or might work in just some places and not other kinds, depend on the soil type. So there are a lot of questions, but very, very exciting work that they've done.
And I'll say, on my way to the question, Paul Hawken tomorrow, or on Saturday, will be presenting research on scaled-up application of things like this, so that'll be a chance to hear it. Go you and then Dave.
Ellie, may not have understood, but it sounded like you were saying that trees would deplete the water out of the soil more than shallow-rooted plants. But it seems to me that the shallow-rooted, where the water does penetrate deeply, the water will just stay there. While if the trees pull it out and transpire it, then the total amount of water that's available in the environment is actually higher.
Yeah, thank you. Okay, I'll try this one now. Does this work? Yes. Thank you for that question. Some recent research shows that in more dense forests up in the Sierra Nevada, that you are transpiring a significant amount of water from the soil. So an ideal forest from a water point of view is one that is more savanna-like, where you have more open spaces and actually allows the water to go further into the soil and out to the creeks and further downstream. But when you have very densely packed forests, like we do in a lot of places where we have made sure that fire hasn't occurred over the past 100 years, you're actually creating a fire trap, and you're taking a lot of water out of the soil. So it's an interesting trade-off. One of my colleagues at Point Blue, who runs our Sierra Nevada program, compared it to a major investment. Like, you could decide that the most important thing you want to achieve, and this would be a policy decision, is to sequester carbon more than having water flow. And it would be like saying, okay, we're going to make an enormous investment with a high risk, but it might work for 10 years, 20 years, 30 years to sequester a lot of carbon, and then you might have a fire and lose it all. You might try to invest in a different way, like the mutual fund approach, and spread it out a little and have lower risk. So they're political decisions, really, that need to be made based on the science. Like I was touching on in my talk, our belief is that multi-benefit approaches are critical. It isn't just carbon. Like, we need water to survive, and we're losing snowpack so quickly, faster than it has been projected for us in California. That doesn't mean we won't have future years with big snowpack. We probably will. But the overall direction is declining. And what does that mean for the snowpack that provides 60% of water for California? It's pretty significant. So we need to look at all these different issues together, and through collaborative, cross-sector efforts, make decisions. We're going to have some hard decisions to make. There will be some losers, but there can be winners in our climate-changing world. We just have to work together and be real clear about how we're making those decisions, and make sure that we have monitoring of it so that we can assess what's working and what's not, and keep improving upon it.
Ellie and Renata, this maybe is a question for Paul tomorrow, but the total amount of carbon coming into the atmosphere is around 9 billion tons per year. And
that's globally?
Globally, yeah. And so the question is, what at build-out, what's the maximum potential for carbon uptake? Is there any real evidence about the total numbers? The second question is, what happens to those numbers, whatever they might be, as ecosystems get hotter, more heat stress, and droughts, and probably invasion of various kinds of pests and so forth we don't know about. Third question, and this, there are 4 more to come.
I can't remember all this.
This is a hard.
You are taking notes, I hope.
Teo told me I didn't have to study for this.
He lied. The third question is, and this is maybe speculation, but what kind of policies would have to be in place to maximize the effect of enhancing ecosystems? You're talking about literally millions of acres of land have to be in some way harnessed. So the question is kind of a speculative question. What has to happen in terms of policy? And would that entail possibly changes in our notions of property and ownership? So the first question is just magnitude. How much? Second question is, what's the effect of climate change, particularly drought and heat and so forth? And third question is, how does it happen in terms of policy?
Okay, first, I don't know. Second, no. The first one is I really don't.
This is a great quiz, by the way.
And I welcome your input. But there haven't been a lot of studies. There are estimates for how much, for example, changing practices on rangelands across the world could sequester, but there's not a lot of science behind it. And that's part of what we're trying to do here in California, is to provide some of that science along with what the Marine Carbon Project and Wendy Silver has done and others have done in Southern Africa. And, but the potential is significant. So for us in California, if we only had on average, which I think is a low estimate, 1 ton of carbon dioxide equivalent for every acre managed better of rangelands, and we have 40 million acres. Let's say that in 10 or 20 years, when the right policies are in place, that we really are doing this on all rangeland acres in California. If we were comparing that to total emissions last year, the number we had earlier today, I think it was 450 roughly million metric tons. So That would make a dent in it. It wouldn't be the only thing. But if you combine it with all the other kinds of things we're doing, from reducing vehicle miles to moving to electric cars to building energy efficiency and so many other things, it actually would be a significant contribution. Also, earlier today, we heard that in California, for example, we are moving from what was I think, a 30% renewable energy goal for 2020, which we're well on our way towards achieving, to, was it 50%? 50% by 2030. One of the reasons that there's this perfect storm, in a sense, to work with local government is that they're trying to figure out, what do I do beyond vehicle miles traveled and building efficiency to actually reduce carbon impact, or to reduce my carbon footprint. And so that get to your second question, what happens with climate change and impacts on lands? If we're aware of that and we manage for it, we can at least mitigate some of the worst impacts. We can slow it down. We do a lot of work in the ocean as well, and there's not a single thing you can do in the ocean, but you can reduce human impact so that you give species more time to adapt. You can protect food web hotspots. So the same thing on land. You can find ways to slow down the impacts. If the soil's holding more water, we would have some places that might have green grass today, even in 4 years of drought, and they've shown that in other parts of the world, like in Australia, where where they have some areas that are managed well. So we know that it can be enhanced, but there's no question that if we have many more extreme events, it can definitely impact those ecosystem services that healthy systems provide. On the other hand, we've also seen that there's ability of some species to adapt to climate change. And so you might see some species increasing that could sequester carbon much faster than we ever thought possible. For example, in San Francisco Bay, there's an invasive kind of plant that we've spent millions of dollars to get rid of. But one time I asked them, what if we thought about this totally differently and our only goal was to sequester carbon? You might want that invasive plant because you could suck up carbon so quickly in just a few years. Again, there are these big questions. They're trade-offs, and we have to come to them with people representing different sectors, think through what we want to do, prioritize, assess, and keep coming back and revisiting and assessing what we're doing to improve our outcomes. Last question was the economic question, I guess. I come back to cities and impact on lands. Is that what you're asking?
Well, what has to happen in policy?
What has to happen in policy? It's starting to happen. This is the first year that we actually have nature-based solutions talked about in state policy in California. The first time in 2015. I mean, fantastic. I keep thinking it's about a decade too late, but I'm happy it's now. And we are, leaders globally. And so I'm imagining it's not in many other policies. So we need to step it down. We need to be sure that local governments are thinking not just of this emergency response, which is to put up that gray infrastructure, but thinking about what's the mix of green and gray infrastructure to meet the challenges of the future. It has to be integrated into policy on every level.
Great. There are probably 100 more questions. We are actually out of time, but I encourage you to corral and, pepper these guys with questions. Let's give them a round of applause. And we've got a shortish window between this panel and the next.